Okay, so today we're going to start with probability. You will have two chapters in probability, which will be discrete probability distribution. As you can see here, discrete means whole number, and you will have continuous later. So inside here, you will have two distributions. One is binomial distribution, and one is Poisson distribution. Okay, so let's look at your learning outcomes here. So basically your learning outcome, I'm just going to cover binomial today. So you've got to define what is discrete, define discrete probability with relevant parameters. Relevant parameters means what distribution is it? Is it binomial? And if binomial, there are certain parameters that we will go through later. Okay, then you must be able to recognize which is binomial, which is Poisson, which I will go through with you in a bit. All right, so the first thing is your probability is divided into two. Now we are doing discrete distribution. You have continuous. So discrete distribution, you have binomial and you have Poisson. So today we are going to do binomial. Binomial distribution will give you two information. One is n, which is the number of trials, and one is p, all right, the success of the event. Okay, so n will be number of trials, p will be success. That means the probability of that event happening or not. All right, so now let's look at inequalities first. You must get to know what is this first. So if I'm saying greater than 3, what is greater than 3? Is 3 included? No, it's bigger than 3. It is 4, 5, and so on. Okay, so you can see two ways there. It's 4, 5 and above, or you can just take 1 minus 0, 1, 2, 3. It's the same thing. Why 1 minus? Because 1 is total probability. And then you have greater than or equal to 3, which is 3, 4, and 5. Okay, and above. So 3 is included here. So you 1 minus 0, 1, 2. Okay, so same goes to the examples on the bottom. Less than 3 is just 0, 1, 2. You must get used to the term. What is at least? At least is 3 or more. What is more than 3? 4, 5 and above. Not more than 5. So I want you to fill it up in your table. If you look at your manual, there is a table. Please fill it up. Okay. So let's look at binomial distribution. There are few steps that you need to actually do in order for you to answer the question. First thing, you need to define the event, which I will show you in a while. Then you define the probability distribution with relevant parameters. Okay, then you use the formula to solve the problem. Okay, first, the challenges that you are going to face is to recognize whether it's binomial or not, which I will teach you now how to do it. And the inequality requirements, meaning if they say at most 3, what's at most 3? 3, 2, 1, or 0. Okay, decimal place requirement. All probability answers must be in 4 decimal places. All right, so let's look at this. You must define the event, and that is how you define the event, with the 3 lines. Do you see X with the 3 lines? So your event will always start with number of. Why number of? This is discrete distribution. Discrete distribution you can count. Therefore, we use number of. All right, so in this case, it's number of red flowers, or number of times a person wins the best, number of fish caught. You follow the question. All right, so now as we move along, okay, the common factor here is the events are a number of something. That's what I meant. This is discrete, can count, so it will be number of. All right. So there are only two outcomes, whether it will happen or not, yes or no. There's no other outcome. So the probability of success or fail. All right. So the probability of success is P. The probability of failure is Q. So if the probability of winning is 0.4, if P is 0.4, Q should be 0.6. Q is 1 minus P. All right. Okay, and there will be a number of trials. They will give you the n, the number of trials. Okay, like they played 15 matches, 10 lines, 10 times, 5 rows, 10 and so on and so forth. Okay. All right. So how to know it's binomial? They will give you all this information. They'll give you n and they'll give you p. Now I will show you an example here. So this is how you define the distribution: x with the curly line, b, n, comma, p. All right, this is the formula. So the formula is given to you in your formula sheet. No need to memorize, so don't worry. You just follow the formula, put it into the calculator and calculate. Look for the C in your calculator. Follow the steps here. You see the steps here? You just follow the steps and it will be right there. Okay, P is the probability of success. You see, when you define your distribution, X with a curly line B and P, right? N is 6, P is 0.25. So you just plug it into your equation. Okay, for binomial distribution, the mean is N times P, also known as expected value. Variance is NPQ, and standard deviation is square root of NPQ. This one we go on later, okay? Now let's look at this example, example 1 in your manual. The flowers of a first cross 4 o'clock plants are pink. If seeds from these are planted, they'll produce 25% red flowered plants, 25% white flowered plants, and 50% pink flowered plants. The seeds are planted in rows of 6. So this is what I want you to highlight. Rows of 6. Rows of 6 tells you that n is equal to 6. Okay, determine the probability that in a row there will be, can you see what are we talking about here? Red flowers, isn't it? So now when we answer the question, if you turn the page, there'll be a table for you. All right. How do you know it's a binomial distribution? There is n is equal to 6. And we want to know red flowers, right? What's the probability of producing red flowers? 0.25. So if P is 0.25, Q must be 0.75. All right, so the first two steps, like I told you, you have to write your event. X with the 3 equal sign there. You see the 3 lines? Number of, it always starts with number of. In this case, red flowers. Then X with a curly line there, B, you know it's binomial. N comma P, N is 6, comma P is 0.25. Okay, so if you look at the table, I would like for you to fill up the table now. So when no red flower, that means probability of X equal to 0. So now if you look at the formula, how is it filled up? NCX, so N is 6, 6C0 times P to the power of 0. What is your P? 0.25 to the power of 0. Okay, so it's Px, right, the formula, so 0.25 to the power of 0 times 0.75. What is on top there? N minus x. That means the n is 6 minus 0 to the power of 6. Do you see that? Plug it into the calculator and write down the answer. How to get one red flower? 6C1 times 0.25 to the power of 1 times 0.75 to the power of 6 minus 1. You follow the formula and you'll be able to get the answer. All right, so when you compute it, just follow this table here. If you don't understand, then you just ask me, okay? All right, let's look at the next example. A fair die is tossed 3 times. So what is that? N is equal to 3. What's the probability that you get 6? What's the probability I get 6? So now you have what? Your event should be number of 6s. And your binomial distribution, your n will be 3, 1 over 6. Your P is 1 over 6. So you just fill up the table. No 6s, probability of X equals to 0. You use the formula and plug it in. So it's not very difficult. You just have to make sure you write your event, write your distribution, and then you just follow the formula and answer the questions. All right, this shouldn't really be a problem. If the P is in fraction, you solve in fraction. Your final answer also will be in fraction. You understand? Don't give decimals. If the P is fraction, your answer also fraction. Okay? So now let's look at the questions here. I will just go through quickly so you can answer the question. Question 1. What is your N? Your N is 7. Why? You toss the coin 7 times. What is the probability of getting a head? Okay, so when you toss a coin, probability of getting a head is 0.5, right? So your P is 0.5. Why? Because your event is number of heads. If number of heads, then your P must be 0.5. So you follow accordingly. Understand or not? And always find the shortest way to do it. If I say less than 4, what does less than 4 tell you? 0, 1, 2, 3. You already calculate or not 0, 1, 2, 3, then you just use it. Okay? More or equals to 5. At least 5. You don't go and 1 minus 0, no need. At least 5 means what? 5, 6, 7. You just add it up. Understand? Question 2. A fair die is tossed 5 times. So what is 5? N is equal to 5. Find the probability of 4s. So your event is number of 4s. You write down the distribution N, P. So your N is 5, Y is it 1 over 6? What's the probability of getting a 4 when you roll the dice? 1 over 6. All right, so I'd like you to do question 1, 2, 3 in this situation, which I think shouldn't really, if it's a problem